everybody, I'm Mrs. Pinkerton, and this is topic 1.6, Photoelectron Spectroscopy. And Photoelectron Spectroscopy, or PES, is an experimental technique that measures the relative energies of the electrons in atoms or molecules. PES graphs show the relative number of electrons in their corresponding binding, so we're going to write binding in here, energy. The binding energy can be described as the amount of energy needed to remove an electron from an atom. The electrons with the highest binding energy are the ones that have the greatest Coulombic attraction to the nucleus because they are the closest to the nucleus. Okay, so let's look at one of these graphs. And you'll notice that down here, it has a binding energy. And the y-axis is the relative number of electrons. And the peaks represent the numbers of electrons. And that can vary. So part of the challenge of just reading these binding energy diagrams is paying attention to the height of the peaks as well as the x-axis. And the x-axis is the relative energy needed to remove an electron from the corresponding subshell. And peaks with the highest binding energy represents electrons closer to the nucleus. And usually the binding energy, the highest binding energy is closer to the y-axis, but sometimes they flip it. So pay close attention to the binding energy values. So here's an example. This PES graph directly corresponds to the electron configuration. And so we can use this graph to determine the electron configuration or the element from the graph. And you'll notice here that the binding energy is higher, closest to the y-axis, and it decreases as you go to the right of your x-axis. And this is the number of electrons. So the higher the energy, these are your core electrons, and as you move out, you're headed to higher energy levels. So what you would do is you would start here. This is 1s2. So each of these lines, they don't always correspond to one electron, but here they do. So this must be the 2s2, and that means this is the 2p6. This makes this the 3s2. And then this is 3p, and each of these is 1, 2, 3, so it's 3p3. So let's go to our periodic table and see where 3p3 is to identify our element. Remember, this starts with your 1s. Sorry, this is your s level. And this starts 2p. So this is 3p. And if I go over 1, 2, 3 electrons, it's phosphorus. So I'm identifying this as my phosphorus. And if I wanted to write it out, I'd write 1s2, 2s2, 2p6, 3s2, and 3p3. And that's how you read the graph. So can you determine the element by the graph below? Pause the video and see if you can. Okay, so here again, the binding energy is highest over on the left and lowest on the right. And again, like I said, please be careful because sometimes they flip this. And if the binding energy said 100 on this side, you would write the electron configuration going towards your left. So you might have examples of that in your practice problems, but just be careful that you understand which side of the y-axis is the higher binding energy. So this is the higher side, so we're going to start with 1s here. So it's 1s2, and again, each line represents one electron. Again, that's not always the case. It could change. So this must be 2s2, and again, this must be 2p3, because it goes up 1, 2, 3. So if I want to find 2p3, I go up to my p block, which is here, and I go over 3 spots, and I have nitrogen. So 1s2, 2s2, 2p3, and this is nitrogen. And again, the tricky part of reading these graphs is just paying attention to the scale of the peaks and the binding energy, which direction it's going in.